Yeah.
Sweet. Well, this will be a good one for everyone. I mean, this is geared towards three different types of people, I'd say. People that come from an R background who, you know, want to learn Python and also want to learn how they can be effective in a multidisciplinary team. Python users, if you're wanting to know what's going on out there on the R landscape, this will be a really good presentation for you. And then also data science managers that want to know about like how to get teams to work effectively together. I think this will be on point for that type of group as well. Do we have any data science managers in the audience? If you don't mind, let me know.
That's a good question.
Okay. Oh, we do. So Michael, he's a data science team manager. Alex. Okay, cool. So, this will be good from your perspective as well. It won't just be, we're not just going to be talking about tools. We're going to be talking about kind of how to get these two teams working together effectively. So it'll be good for you. All right. Cool. So let's get started here. I think we have, looks like 137 people or so. We're here to talk about R and Python in collaborative teams. So using both of these tools together effectively and really leveraging this idea of collaborating and using the benefit of the team and these differing perspectives to really help produce even better results. High performance team, if you've ever heard of that term before, we're going to be talking a lot about kind of what makes a good team. So to get started here, I want to kick this off with a quote from Michael Jordan. While Jordan was, at the top of his game when he played, he's arguably the best basketball player ever. This quote from him, though, really resonates with me and with a lot of people because, he's talented, but what wins championships isn't necessarily the talent alone that wins games, but it's the teamwork and how you guys, how the composition of the team, they all have to bring differing backgrounds and perspectives and skills to be able to collaborate. And that's what wins championships. So this is from Michael Jordan. And although he's talking about sports, the same is true in business. We really need to have, it's not going to be you alone most of the time working on projects. Some of these projects are going to be bigger and they're going to be, they're going to touch multiple different parts of the organization. And you really need to be good at working in a team environment. And that's where R and Python can actually be a strength, having people that are really comfortable in both. So first, what I'm going to talk about here is actually nothing to do with programming in general. We're going to be talking about team composition and this idea of cognitive diversity. So I've been doing a lot of research here over the past couple of weeks as I've been putting together my new course. And one of the things that I'm really focused on is how to get teams to work effectively together. So there's this concept of cognitive diversity, and this is something that there was a nice article written by Harvard Business Review where the authors talk about this concept of cognitive diversity. And it's basically when you have a team with members that think differently, and they tend to perform better than when you have a team with members that all think the same way. So it's the challenge here is it's less visible than other forms of diversity. So you may have heard of gender diversity or ethnic diversity, and it's kind of like that. And certainly teams that are gender diverse and also ethnically diverse, that can help contribute to cognitive diversity because these people tend to have different backgrounds. But the idea here is that these teams that think differently, it really accelerates learning, especially when faced with new challenges, which is something that in businesses you're faced all the time. So they did a lot of research, and what they kept noticing was that these teams that had kind of these differing mixes, tended to always end up on top. So they actually put together a study on it. And what they did was they measured two different metrics. Or one metric is called knowledge processing, and another is perspective. And I'll talk a little bit more about those on the next slide. But what I want to show is the results first. The performance, they saw there was a high correlation between these differing teams. And if they had a good mix, and a mix is defined as a standard deviation of knowledge processing, so they ranked these people based on their surveyed knowledge processing, whether or not they liked to deploy existing knowledge, or they like to preferred to generate new knowledge during when faced with new problems. And that's kind of like a scale of like 1 to 10. And then you have another kind of spectrum where you have perspective. And that's where individuals prefer to deploy their own expertise, or if they prefer to orchestrate new ideas. And then they rank the team members, and what they wanted to know was what was the standard deviation on that team of their perspective and their knowledge processing. So these teams that scored more highly in the standard deviation of these within their composition solve these challenges that they were faced a lot faster. So in the real world, what does this look like? So having a high cognitive diversity on a team means that you have different team members, and they kind of match up differently. They're not kind of lumped together in any one quadrant on this continuum. So for perspective, you might have a team member right here who prefers to deploy his own expertise. So he's very confident, and what he wants to do is leverage his own skill sets to be able to deploy solutions. And then you might have a team member down here where they are prefer to orchestrate other solutions that have done it before, or they might prefer to leverage different, and we would call this one up here confident, and this one down here risk averse. And then the same thing with knowledge processing. So some people, like this person over here, prefers to apply new technologies to solve problems. So this is the classic type of person that likes to be on the bleeding edge. And then you've got people over here who prefer to use existing solutions that have already been done previously within the organization. And I call those people the historians. So when you have a mix of people, you have a higher standard deviation on these kind of metrics. And that's what they saw was when they ranked people, they generally teams like this, where it might be a 5-person team that was spread out and had these different backgrounds and perspectives, they tended to perform better. So that's kind of the idea of a high-performing team. Now I want to talk about the myth and how this relates to the teamwork. So the myth here is R or Python. You have to choose one, right? Well, that used to be the myth. So what most data science teams out there have kind of done is standardized. And they tend to kind of ask the question, what type of shop are you running? Are you running an R shop, or are you running a Python shop? And as soon as you do that, it forces you to kind of pick, and that choice does something to your team. So it tends to, what I'm seeing is it tends to affect the cognitive diversity on data science teams. So you have these two different skill sets, R and Python, and they tend to have, packages that are designed more for those people. They also have kind of different personalities of people who tend to prefer Python or R. And what I'm finding is that people that come from the same backgrounds, meaning they use either R or Python, a lot of times they tend to think the same. Everything looks like a nail, right? So if I chose R and I'm on a team full of R people, well, then we're all trying to use, maybe the latest statistical package in R to perform something. But a Python package could have possibly been written that would totally streamline our efforts and maybe save us, weeks of development effort. So The problem is that when you choose and you make yourself an R shop or a Python shop, you really, you lower the cognitive diversity on your team, whether you like it or not. So that's one of the issues. It also, and I kind of alluded to this earlier when I talked about, Python packages or R packages being developed. So when you choose Python or R, you're automatically now confining your people, your team members, in order to be able to use Python or use only R. You now have kind of isolated yourself from potential packages and solutions that already exist. So in R, I have a few here. The Tidyverse, which is amazing for data wrangling. Model Time, which is my own model time software for time series. TidyText, which is a really user-friendly text manipulation library, and a few other libraries here on the R end. And then on the Python end, if you choose R, you're potentially limiting yourself from some of these really powerful packages like scikit-learn, TensorFlow on deep learning, Spacey for natural language processing, and so on. So it's often a better idea not to limit yourself. One final thing that this does is it actually, from an HR perspective, it reduces the number of people that are now candidates. And this potentially hinders you from, not being able to hire people who may have the talent that you need, but they just might be in the wrong, language for your quote unquote shop. So when you select, either Python or R, you end up cutting out a proportion of your potential candidates, which is not good from a hiring perspective. So to move on, I want to talk about what's perceived, and this is what I hear a lot of times, and this is one of the reasons and the rationales. But everyone seems to think in terms of tools, and this is a classic data science workflow diagram that I see floating around on the internet. And these diagrams, they're great for showing people and selling to people tools, but what they're not really good at is actually explaining what's going on. And you might see a diagram that looks like this, where it's got Apache, Spark, it's got TensorFlow in here, all of these buzzwords, EDA, and then at the end of this monster pipeline that connects up mobile apps all the way through your relational database management system using NoSQL, which doesn't make any sense, and then Kafka, and then all of a sudden you've got a presentation that you're making at the end. And this is a great for a consulting slide deck when you're trying to sell something to somebody. It's confusing as heck, but it's just it's all emphasizes the tools, and it doesn't emphasize what's really important, the process. So this is a different diagram. This is one that I made a while back, and this is really, I think, what's most powerful is the concept of developing a team. Is really not to focus on the tools, but it's to focus on the process that your business needs in order to be able to produce results for any type of problem. So what you want to do is you want to have a team that is really skilled at diving into a business problem, which will come from your business, and producing business value at the end. Because that's really what your team's going to be measured, and also the manager's performance is going to be measured on that. So in general, there's several stages and steps that you have to come through in order to be able to go from business problem to business value. And you need to have the tools will only help you, but the tools aren't necessarily, it doesn't matter if you use Java if you wanted to, or if you use whatever programming language, even Excel. If you're very skilled at going through these stages, use the tool that you're most confident with. But the idea here is that you need to be able to come through this process, and those teams that come through this process the fastest are normally the high performing teams, because they're able to iterate. And they're able to generate results fast. So we'll come back to this diagram in a little bit, but this is basically what I find important in teaching data science, and also in the real world and actually applying data science, is to be able to come through this process. So the real challenge isn't necessarily, developing these crazy systems. The real challenge is to be able to come through this process and have your team work together effectively. So that's what we're going to talk about next is this idea of R and Python working together. So traditionally, R and Python has been a debate, and this has been debated. It's like any type of new language or new even I think programming back in the 90s, it was probably Java versus JavaScript or something like that back, so there's many examples of these programming language wars. And I think this R versus Python debate is just like that. It's a lot of pointless fightings. You've got, the army on one end, which is the R people, and then the Pythonistas on the other end. And they're constantly battling each other because you feel like your organization has to choose one or the other. And if you're not on the right group, then you feel like an outcast. And, that may have been the situation back, in 2015, but we're in 2021 now. And a lot of things have changed. Most importantly, technology has kind of recognized that this collaborative effort needs to happen. So now we're in 2021, and we're now saying that we can work together, both, having our people on the same team, Python people on the same team, having everyone use their skills for what they're good at. The R person might be really good at data wrangling and statistical analysis. And the Python person might be really good at machine learning and maybe maintaining, models over time and watching and analyzing for drift and those sorts of things. So you put these people on a team together, and then you're able to accomplish some really powerful things. But it's how do we communicate? And that's the thing that that's going to be the biggest challenge to these R and Python multilingual teams. So there's a new technology out there called reticulate. And this is really helping to kind of bridge the gap, at least for our users, to be able to more easily be able to communicate with Python people. And that's a really powerful idea, is this idea of being able to write Python right from the R console. I actually have a running demo of it here, where I have an R script where or actually this is a .py file. And as soon as I hit Control and Enter here and import pandas, you can see this reticulate REPL. Now I've got Python 3.7.9. It's connected up to my user environment for this 204 development. And I'm now writing Python. And as soon as I import this, GA page path is now a pandas data frame. If I check out the GA, if I run the type function on GA page, what is it? Page path underscore date df. We can see it's a pandas core data frame object, and I'm running it right from RStudio. So that's all powered by this idea of reticulate now being able to let the R users use Python. And this is this is not a brand new technology, but it's certainly been an area where RStudio and who's developing this has been investing a lot of time and resources. So we just kind of saw, what this allows us to do, be able to use R or Python inside of R, but really this is a communication tool, because it now allows us as R users to give our Python counterparts, our teammates, what they need, which is code written in Python that is dependency free of R, that they're able to just kind of, as long as they install the Python packages that you're using, they can then run it. And that's a really powerful thing. And there's certainly other ways that cross-functional teams can communicate. There's other products out there, but this is the only open source one that I'm aware of. There's also, Databricks. I've heard a ton of good things about that. I don't specifically use that, but that's another one where you can use kind of R and Python together, and it allows for, this collaboration to happen. But the one that I'm going to focus on is the open source tool Reticulate. So that solves kind of the teammate problem, but we also need to think about what our end users need. And this is normally not R or Python, but rather either an application or an Excel file, some sort of data product, a report. These are the types of things that we really need to be able to collaborate on, is to be able to produce these efficiently and effectively. So this is an example. I'm going to pull up this application here right now. This is a live web app that actually does forecasting. And this is what most businesses actually need. So this is an automated forecasting app. Your business may need a forecasting app, or it might need something totally different, like maybe they're really interested in customer churn. So an application developed around that. And when you learn how to build these types of products, then that's where the business leverages the value. So it doesn't really matter R or Python. This is an app that was built in Shiny, which is an R product, but with Reticulate, you can now import the Python libraries and run Python under the hood too. So your Python teammates that are building models in Python, you can now display those in this technology called Shiny. So it enables going back and forth, and it's really powerful as a collaborative team to be able to really leverage the benefits of all of the people that are on your team, rather than just feeling like you have to pick one or the other. So that's really kind of the idea. So the reality here is that these two programming languages, they've kind of grown up differently. Most of my background is in R, and I will be honest, that's kind of what I've grown to love and to use over the past few years. But now I've also been learning Python, and it's been really exciting because there's a lot of stuff that I didn't even know about in Python that is very useful as well. One of the things I want to showcase first, though, is the R kind of toolkit. So this is what I've been developing over the years, is kind of understanding, where each of the R tools kind of fit into this mix. So R has a really powerful set of tools. And if you're a manager on a team where you're looking at having R people and Python people, here's where I feel that R people can contribute. The R people tend to be very good at doing data wrangling and statistical analysis. That's a generalization, I realize that, but there is a very robust set of tools in the R language called the tidyverse, which allows us to do data wrangling. And I know Python has pandas as well, and it's good. But I think there's something to be said for the fact that 80% of what we do as data scientists is data wrangling. You should definitely have somebody that's skilled in data wrangling on your team. There's also in the R toolkit the visualization and the machine learning, and we've got some robust sets of tools that I'll talk about a little bit more here in a minute. One of them that I'm going to showcase in the course that I have upcoming is H2O, because it's available both in R and Python. So it makes a really good common ground for these teams that work together to be able to operate. And then another reason that R is good is because of the R Markdown and Shiny, being able to stand up these web apps really quickly. That can be very valuable to an organization. So Shiny is a robust set of tools for basically converting your analysis, packaging it into a web app. And that's what we saw here with Nostradamus. This is an example of the Shiny web app. And you can see we've got an analysis that was done. We click the run forecast button. It makes a bunch of different forecasts. It created a bunch of different models here that were made with actually one of my R packages called Model Time. And that's designed for forecasting. Okay. So we talked a little bit about R. I'm going to kind of skip through a few of these slides. We've got data preparation. We've got visualization. We've got, when you combine data preparation with visualization, you can make these nice plots. And we've got machine learning. So it's got a nice set of tools there. And the example here from the app is where we saw these models that are all varying in different importance. You've got packages like H2O and Tidy Models that help you do that. And then the communication and is building, an app that uses a technology like Shiny, where you can package that analysis that you've just done and put it into a web-based application. Okay, so that is all fine and good, but that's in R. And if you guys are interested in learning more about the ecosystem for R, David is going to give you a link right now to what's called the Ultimate R cheat sheet. It's a data science workflow. I'm going to pull it up real quickly just to explain what it does, but it's got these hyperlinks in here where it links to each kind of section that I just talked about. And it does have 3 pages. The first page is probably the most important if you're a beginner in R. But what this does is it links to all of the key packages in the system. So I'm just going to click one here, dplyr. You can see it opens up the website for dplyr. And you can quickly see, where each of these packages fit in that workflow. And it can be a useful thing, especially if you're learning data science. There's also cheat sheets. So if you see a CS, you can click on that and that'll open up another cheat sheet for that particular package. Okay, so that's the R ecosystem. But what about Python? So many teams prefer Python. Well, Python has a robust set of tools too. Now, I'm still working on this cheat sheet, so it does only have 1 page as of right now. David's going to give you a link to it. So the idea here is that you've got kind of the same type of process, but you've got different packages here in Python that allow you to do the same thing. So pandas is a big one. You can see it covers kind of a couple different areas. You got visualization, matplotlib. So if I click matplotlib, right here's the documentation for it. So Python has a very kind of, I'll say similar set of tools, but the strengths in Python, in my opinion, really lie on the modeling, machine learning, and also in the deep learning ends. They have a robust set of tools, SPACY, NLTK for natural language processing. Some of these, I haven't had a chance yet to put into and consolidate into the ecosystem. So I will be doing that over the next coming months. But as of right now, I have kind of just this 1 pager that David's going to give to you guys. Okay, so we now see that we've got these 2 ecosystems. We want to be able to kind of collaborate. So what's coming? Well, I have a course that's coming that I'm working on right now. It's called RPython Collaborative Teams. And what I've done is I've really kind of thought back of kind of an innovative way to, or at least I think it's innovative, a way to present the material and show how we can actually develop using, from an R user's perspective, be able to collaborate with a Python team, with teammates that are in Python, and be able to produce results that the organization needs in either fully in Python or using APIs and that sort of thing. So the problem that I've picked is one that David and I are actually really familiar with. It's called email lead scoring, and this is what we commonly call the holy grail of marketing. So it's basically, if you're able to take everyone in your collection of email list that you have for your company. So from a marketing perspective, this is really important. You've got an email list, every company has one, and they may send out emails, once a month or once a week. And what you want to do is you want to be able to score those people that you're sending emails to as to where they are on their in their kind of behavioral perspective of, are they getting close to being ready to purchase something, or are they still in that beginner nurturing phase? So this is a really powerful problem. It affects every company. So what we're going to do is we're going to build a predictive model that determines the probability of a product purchase. And we're going to use email subscription data, and we're going to use in transaction purchase history. So the idea here is, you've got awareness, you've collected some sort of email here up at the top of your funnel, and then you've got people in your email list that are kind of in this phase here, and you want to determine where they are at in that phase. And we can do that using data science. It's actually something that I've just recently started tinkering around with, and we've just completed it at Business Science, and looks like it's pretty powerful. But basically, this is the project. We want to be able to assign a probability of making a purchase. And the use case is email marketing. The high probability people are going to get sales emails. The low probability people are going to get nurture emails. And your goal is to try to take those nurture people, move them down farther down the funnel to get them into that kind of sales email sequence. Okay, so very powerful product. And this is something that every company can use right off the shelf, which is why I'm giving it to you. I want you to be very valuable to your company. So through this process, you're going to learn Python along the way. So the project goals are, to solve this major business problem that's going to increase revenue, profitability, and reduce email churn. And you're going to leverage your R knowledge. So this course is designed for R users. And you have to, or you should have some knowledge of dplyr, ggplot2, and H2O for sure, because those are going to be the core packages that we're going to be replicating in Python. The learning objectives, you're going to use your R knowledge to formulate strategies and statistical reasoning, and you're going to learn reticulate, and you're going to build full Python code bases. So you're going to learn Python along the way. It's something that it's a project-based approach, and this type of approach tends to be very effective in getting you skilled up to be able to work with your Python counterparts. So just a summary, what I'm trying to do with you is to be able to teach you how to give end users what they want. So the course is designed for our users. It teaches you how to give users what they want. So those users could be your teammates that work in Python. Those users could be executives that need Excel data products, Excel worksheets or workbooks. It could be people in the marketing department that just all they need to have is the segmented email list of, hey, these people are high targeted, or these people are should be used for nurture. It's going to teach you how to convert your R code bases. So you think in R, but how do you convert that to Python? It's going to teach you how to do that. So you have no R dependencies in your code bases. That means you can hand it right off to somebody who works in Python, and then they can take your analysis and kind of move it into production or whatever they need. And also we're going to focus on another key type of product that my students have asked for is for building language agnostic APIs. So this is something that you can build an R API or a Python API, and then it becomes really powerful because the tool that you connect up to it, whether or not it's Excel or Power BI or something like that, it can connect right up to an API, and it doesn't have to worry about having R software or Python software on that computer or server. So it can just communicate and leverage those models that you've developed. So those are the kind of key ways that I see Python and our teams working really well together, is to be able to have teams that can kind of communicate back and forth. Maybe they're not, maybe they prefer R, or maybe they prefer Python, but they have at least enough cursory knowledge to be able to convert code bases. And then they also know how to build APIs and to automate certain parts of their process to perform these really powerful projects.